Welcome to Sailing the Storm here on TradeTV. I am your host, Tremaine. Today, we're joined by Green Spark, a company all the way from Kazakhstan. So, hi, Dejan. How are you? And kindly give us a brief about yourself and your company.
Hello, thank you for inviting me for this interesting journey. I'm the head of engineering of the Green Spark, and the Green Spark is founded and with headquarters in the capital of Kazakhstan, in Astana. And we have offices around the world. Also, we have our production area and workshop in the North Kazakhstan. Also, we have an engineering unit here in Serbia, where I'm head of the office. Green Spark is founded in 2017. And the main business area was energy and oil and gas, engineering, supply chain, and fabrication of equipment for oil and gas. In parallel, we started the unit for renewables. And today, we are proud that we executed more than 15 projects, small-scale projects, mostly for the solar and green energy production, also green hydrogen production, and biomass to energy projects.
Short on time, feel free to use the chapter markers below and speed us up to match your pace. So, please give us an overview of this project and what made it especially challenging for Green Spark.
This project is, let's say, combination of application, one of RD projects that we did in the past, research and development. The point is that demand in the hydrogen is increasing in the world because it's a very important component for the emission reduction and reducing the CO2 emissions. Laboratory is installed as a part of the refinery in the southwest Kazakhstan, close to the Caspian Sea. Refinery is using this laboratory for testing the products and components inside the plant, and refinery is purchasing the hydrogen from the manufacturers that were producing this gas from with the emission of CO2 with let's say gray or even blue hydrogen. And the idea was that to stabilize supply of this gas to the laboratory, we installed the electrolyzer system that will use solar energy to produce the hydrogen, and that will be available for the usage of the laboratory. So this is the main purpose of the project.
You see, Dejan, we talk to people in Europe, we talk to people in United States, but this is the first time we talk about a project based in Kazakhstan. So, how did the local regulations and site conditions affected and guided design of the layout of the whole system? Please walk us through.
First of all, I would like to introduce Kazakhstan. It's quite a big, huge country. In the area where we installed is practically desert. During the summer, we have sandstorms, and during the winter we have snow and very cold. So each area in Kazakhstan, they have their own requirements regarding the temperature and weather conditions that we have to respect. No matter what client is requiring, there is limitations. For the area is minus 30. Client can say, yes, for me is okay, minus 25, because last 20 years was not below that, but by the regulation is minus 30. Regarding the technical requirements, they have local rules and regulations standards that are quite common and let's say aligned with the International Electric Technical Commission or ESC standards. So no surprises there. Technically, installation in any part of the Europe is more or less the same like in Kazakhstan.
You installed 336 panels around 200 kilowatt on the lab. So how did you decide that size based on the lab's actual energy use so it saves the money without exporting too much power back to the grid?
Practically, we were guided by the internal design of the building. So internal design of the building as a document is called the load list. And this is the list of all consumers inside the building, and it's giving the overall power demand of the building. So based on that, plus including the power that is power consumption from the electrolyzer, it was calculated that the roof size fully covered with the chosen panels is enough for the supply without any problems of the of the partially to supply energy to the building.
Many green hydrogen pilots use PEM, but this project uses an alkaline electrolyzer. Dejan, why? Why was alkaline the right fit here? And what did that choice force you to do differently in terms of power control?
This is after detailed design and the sensitivity analysis that we are doing. We are choosing the right technology. Right technology in the case, this case where the system not critical for the operation of the building, as this building has a redundant supply from the grid. We have chosen the alkaline type of fertilizer because their durability, their easy maintenance, and they are much, the cost for them are lower comparing to PEM, because PEM is using quite high-end exotic materials inside, and it's their price is quite high.
So, Dejan, what challenges came up when connecting it to the solar?
Synergy between three systems. So one system is power supply from the grid, that is internal grid, that is grid inside the plant, is completely isolated from the district grid. We have the solar inverters that are connected to the AC distribution board that is controlling, and network analyzer that is controlling production of the solar energy, and electrolyzer. So all three units are functioning in a synergy control by the network analyzer, and transferring the production to the optimum level, let's say, for the solar system.
Then one of the biggest risks you highlight is reverse power flow. So what protection devices and logic did you build into the AC distribution board to make sure that the system doesn't feed power back into the utility networks?
This particular case was solved with using the specific model of the inverter, Atyrau, that can monitor this flow of energy. Also, we were using energy analyzers that following flow of energy, and let's say soft control was practically that the inverters were reducing their loads and power depending on always positive spending from the local grid. For this margin has to be always positive. For some extreme cases and disturbances, fast disturbances in network, and this we were using the IC port and ABB disconnectors or breakers with relay interfaces that are very fast and doing their job, switching off the complete solar power system. So the energy will not go back to the grid.
Weak and stable grids are common in remote areas, as you have mentioned. So what strategies help you keep the PV system running safely and reliably, Dejan?
This particular project, this network for this kind of plants is quite stable. We didn't have any issues, and for the remote areas in Kazakhstan, disturbances are quite often. Network can have a fluctuation in voltage and also in the frequency. So usually we are protecting our systems with AC boards and the network analyzers, PLC systems that are monitoring the parameters as per ANSI codes, and if any disturbance is detected that can damage or jeopardize the equipment, leads to immediate separation from the district grid.
Dejan, we heard that you develop an AI platform that integrates with the inverter supervisory control systems. So what are the best features that you can share that deliver the real value and made reliable for the project?
So each situation, each project, for the solar system that need to provide power, electrical power, are different. Practically, our AI platform is learning from the actual situation from the consumers, where are the peaks of the consumption, everything, and adjusting the production of solar electrical energy. This is one of the main purposes how this AI should work. Also, the second one is to prevent any backcharging of the energy to the grid by controlling the inverters. They will practically reduce their production based on this parameter, and also to improve the maintenance, giving the information from the temperatures from the other instruments, and some probes we have that are collecting information, and let's say for predictive maintenance. This is the correct, let's say, word. This is one of the main features that we expect from the
So definitely I can say that it's an age of AI. So Dejan, just on a personal note, I want to hear what's your take on the integration of AI to this solar project. So what can you say and what are the things you have observed so far?
This is for us is like revolution. So because all these systems we have online, we have to monitor. We have people that are looking into the how the system is breathing, how to adjust it in a certain time, and they are collecting data, making analysis and everything. And with AI, it's practically it can be stressful for the guys that are responsible for this part. And self-learning of the artificial intelligence is amazing, and it can be very helpful. Of course, our specialists with reduce quite significant reduce of workload are still monitoring all this and how it's performance, but their workload and number of them is drastically reduced.
That's very insightful. Thank you. And Atyrau has hot summers, winter, and dust storms. So, what equipment specs and maintenance steps mattered most for keeping the PV inverters and electrolyzer reliable in those conditions?
Well, first is to choose the right equipment that is suitable area and for the climatic conditions in this area. The second one is to make the proper maintenance procedures that the client need to follow up after the installation and commissioning is finished. This includes monthly checks of the equipment. Or the requirements are that the specialists are going to the roof to check the panels are damaged, if there is any, if cables are okay, if the panels are clean, and they are doing the cleaning also. Usually during the summer they are doing the cleaning of the panels. So this is the way of how the post commissioning and startup activities are done on our systems.
So, Dejan, were there any disruptions to your local labor availability or supply chain during the whole construction process?
Our experience is coming from the oil and gas energy sector that is quite demanding. We transfer this type of project management from oil and gas to the renewables, and it's quite functioning well. So especially during construction, where is the safety is the first thing to avoid any incident to the equipment and the people that are working. This is the most risky part of the construction. We are well prepared because we are just used to this environment. We don't have any problems or challenges there regarding the workforce, type of working PP. We have the safety officers, quality control system and officers there working. So practically no any issues on this matter.
If you had a chance to jump into a time machine, would you do something differently to make things better?
We have some approach that is not in that way that we would change something. Any project is very valuable for us because it's giving us experience for the future.
And that's a wrap for our episode today. Thank you so much, Dejan, for joining our show today, and of course to your team at GreenSpark.
So thank you very much for giving us this opportunity to present our company and our projects.
This has been Sailing the Storm, only on ENF TradeTV.